Hello everyone, welcome to Shree's Coding Hub. Today's episode, we are going to discuss what are arrays and what for we use arrays and what are the advantages and also disadvantages. By the end of this video, we will get a good idea what are arrays. Now, without getting late, let's get started. Here I am opening my Turbo C++, a new file. Now I am declaring main. Now, here what my requirement is I want to store 100 values from user. I want to store 100 values from user. So now we till now, how did we scan a value from the user? We used a scanf percentile d comma address of a. Super, it's very good. Now here uh, for one value it is okay, it is very satisfactory, but here I need to scan 100 values. Here I need to scan 100 values. If we do something like this, uh, comma address of a for the same variable, uh, I am saying it, if we do with the same variable two times scanning, and now what I do is printf. If you are thinking something like this, what it results, let's see. F9 to F9, I am giving 1 and 2 times I have given 1. So okay, but here I am changing slightly. Here I have given input 1 2 times, but I got only single one. Here now it is saying statement missing. Now what I do is I give 1 and 10. Now you can see the output. Uh, Only 10 got printed. Only 10 got printed. Here if you observe, scanning 2 times in the same into the same object will remains something like this. It can hold only the last value. It can hold only the last value. Here what is happening? Uh, First 1 is stored in the A object. Again 10 is stored in the A object. But 10 is not stored behind the 1. It is overwriting the 1. It is overwriting the 1. 10 is writing 10 is overwriting the 1 in place of 1. 10 is getting stored. Now when we are printing, only 10 is available, so 10 is getting printed. But our requirement is to print, our requirement is to take 100 inputs from the user. Now if you are thinking like something like this, a comma b comma c, and now I say b, now I say again c. So let's write for 1, enter. Sorry, we didn't write printf for b. Let's define only here slash n, percentile d, again slash n, now comma b. Now here I say 1, here I say 10. Okay, it's fine, we got 1 comma 10. But what our requirement? Our requirement is to store 100 values. Writing a comma b comma c comma d comma e 100, like that 100 variables is not possible. Okay guys, it's not possible and it's not good also. We can't write, as a developer we also can't write 100 variables. And we in English, even writing alphabets we have 26 only. Then for writing 100 variables, for declaring 100 variables, we should use apple, like that. We should use words also, because in English there are only 26 words. But taking 100 objects is not at all good, and it is impossible to scan 100 times. Here taking 100 variables means scan, we should write scanf function for 100 times. It is also not possible. Now what is the solution? Here comes the solution, arrays. Here comes the solution, arrays, today's topic. Now uh, what are arrays? Sequential, let's define the heading first. Arrays, sequential memory blocks, of same data type used to collect used to hold collection of values, used to store collection of values. Okay, Now what are arrays? Those are sequential memory blocks of same data type. We cannot store a int and a char and a float. Like that we can't. We can store only same data type. If we define an array, or we define array something like this, int a, int a of some like 100. Now we want to let's take the example only for 10 5 guys. For simple example you can do for 100 also. Now I took now 5. Now I can store 5. Now I can store 5 values here. Now I can store 5 values here. This is called array. Like this we declare an array. Now sequential memory blocks. Now there are 5 sequential memory blocks. We can't store one integer, one character, one float, or one double. We can't store like that. All the 5 are integer type only because we use data type int. If in case we use char, all the 5 blocks will be only able to store characters, only char type. They can't store integer. So uh, if that's why we said that same data type, blocks of same data type. Now here once I declared 5 here, once I declared 5 here. Now 5 blocks are created. Those are not reallocated, guys. Understand the concept. Those are not reallocated. We can't decrease the array size, we can't increase the array size, we can't decrease or increase, we can't do both. Now what is the drawback? Arrays are fixed in size. And there is also one more drawback we discussed, that we can't store another data type. We can't store any other data types. Only we can store same data types. We can store only same data type. Now how this array is getting allocated in our RAM, how the values are getting stored, let's see. Let's get into a word. Here I given a detailed diagram. Okay, now here in this way int a of 5 we have declared array. Now what is happening in the stack segment? A object is created with some address 6120. Here the address of, the address may be anything, but let's assume in stack segment when we declare a of 5 like this, a object is created with the name we defined here. We defined name a, so that's why an object is created with name a having some address 6120. Now these 5 blocks are not created in stack segment. These 5 blocks are not going to created in stack segment. They are created in the heap segment. There are 4 segments of RAM. This this object A is created in the stack segment, and these 5 memory blocks are created in the heap segment because 5 stack is little bit small and heap is large and stack is small. That's why the memory blocks are created in the heap segment. Now how this A is connected to these 5 memory blocks? Now these 5 memory blocks have different address. These 5 memory blocks are created with different address. Here you can see the address of first block is 7120, the address of second block is 7122, the address of third block is 7124, the address of fourth block is 7126, the address of fifth block is 7128. Like this, the addresses are different. Now what happens here is, the whatever the object created here in the stack segment with some address 6120 with the name a, here the base address of these 5 memory blocks. What is the base address of these 5 memory blocks? The base address means the very first address. The very first address created in the heap segment is 7120. Now this 7120 comes into this a block, comes into this object which is created in the stack segment. Now this consists of 7120. Now this consists the base address of these 5 memory blocks, this array. This consists the base address of this array. Now here 7120 goes into this block, this object, where this object is created in the stack segment. What this object is containing? The base address of this array which is created in the heap segment. Guys, understand the concept please. Now this is the process. Now here if you observe, The addresses are different, but there is a slight common thing in between these addresses. The difference between all address is 2. The difference between addresses are 2. Now first address is 7120 and the second address is 7122 and the third address is 7124. So the address value is increased by 2, is increased by 2. Now uh, in our RAM also the addresses are created by this difference only. In the same manner, the difference will be 2222. The address value will be goes on increasing by 22222, 7120, 7122, 7124, 7126, 7128. Same like this manner only it creates the instance and the address in the heap segment in our CPU also, in our CPU also same. Now uh, now this A object is created in the stack contains the base address of this array which is created in the heap segment, and this A object also has the has some address 6120. Now here how to assign values, how to insert values into this 7120 block, how to insert values into this 7120 block, how to insert values in this 7122 block, how to insert values in this 7124 block. Now here we discussed that the address will be goes on increasing by 22222. Now this is not same in every segment, this is not same in every aspect because it will be changing according to the data type, according to the data type. Now as we know, int occupies 2 bytes of memory in RAM is the same. So that is why the difference between address are 2. The difference between address is 2. In case of char, we know it occupies 1 byte in our RAM. If in case of RAM, the difference is also goes on increasing between address 1111. It will be 7120, 7121, 7122, 7123, 7124 like this. But here we used int data type, that's why the address value is goes on increasing by 22222. Now to insert into this value, we store something like this: a of 0. A of 0 means very first block. A of 1 means very second block. A of 2 means very third block. Now here count is started from 0. In our now here 0 represents very first one, 1 represents very second one, 2 represents very third one. Now why like this? Uh, Actually in our mathematics we start counting from 1, but here count started from 0. What is the logic behind this? Here this calculation is the logic behind that taking value 0 for the first one. Here what happens when we say a of 0, it takes the base address which is in the a. What is the base address in the a? 7120. Now it takes 7120 and adds some value. What is that value? It takes whatever the value we defined here 0 and multiplies with the size taken by this data type, size taken by this data type. Now what is the size of int? 2 bytes. So it multiplies 0 into 2, it multiplies 0 into 2 and adds to the 7120 which is the base address in this. So 7120 plus 0 into 2 we get 0. So 7120 plus 0, 7120. Now here the value is 7120. Now whatever the value we assign here 50, it goes into this address. Which address? 7120. Now here the address is 7120. Now we assigned 50 into that. So 50 came here. 50 came here in the heap segment. Now when we say a of 1, it takes same base address which is in the a, 7120, and plus now it multiplies whatever the number here and size of this data type. So 1 into size of the int 2, 1 into 2 2. Now 7120 plus 2, what is the result? 7122, 7122. Now this 100 goes into 7122. I hope you guys understood. Same with the a of 2. That's why we start this count of array from 0, from 0. This is the main reason behind starting count from 0. I hope you guys understood. If we in case we start from 1, the very first block 7120 will remain null, will remain empty. This block will be wasted. We get only 4 blocks, we get only 4 blocks. uh, that's why it is very important we should start from 0. I also explained this calculation is the major reason starting from 0. 0 into 2 0, 7120 plus 0 7120, 50 goes into the 7120. I hope you guys understood the process. Now let's get back into our turbo C++ and try to write in this fashion. So a of 5 we declared. Now what I do, I declare from a of 0 equal to 100 and a of 1 equal to 200. Now a of 3, sorry, a of 2 equal to 300 and a of 3 equal to 400 and a of 4 equal to 500, a of 5 equals to 600. Now, is this correct? Is this way correct? Now what I do is, uh, I simply say printf percentile d slash n comma a of 0 and printf percentile d slash n a of 1 and printf percentile d slash n comma a of 2, printf percentile d slash n comma a of 3, printf percentile d slash n a of 4, printf percentile d slash n a of 5. Okay, it's nice. Now here, how many blocks we allocated? 5 blocks. So first block, second block, third block, fourth block, fifth block. Array, we defined 6 here. We defined 6 here. Now what will be? Now here if you see, there is no error. There is no error, guys. You can see here, there is no error in compile time. There is no error in compile time. The array size is only 5. Starting from 0 to 4, 5 blocks are completed. But we accessed the fifth block here. But there is no error in compile time. There is only a warning. Now let's link and load Ctrl F9. Let's check the output and then we discuss. Here you can see 100, 200, 300, 400, 500, 600 got printed. Oh sorry, what is this? What happened to our code, guys? Oh sorry, I didn't save it. I didn't save it, I think so. As of I know, I didn't save it. Let me rewrite the code. Okay, now we wrote our code. uh, Here here the array size is only 6, but I have given 0, 1, 2, 3, 4, 5, 6. How many values? 1, 2, 3, 4, 5, 6, 7. 7 values and also printed 7. A of 0, A of 1, A of 2, A of 3, A of 4, A of 5, A of 6. Now, here, if you observe, it didn't give any error. Didn't give any error. But the array size we defined is only 5. Only 5. Now let's check the output. What will it be? Here you can see we are getting a linker error. This is called linking error. When I press link and load, it has given something like this, some unknown value -1 -1. But here if you observe, we got 600 700 also. Here our printf should work until only 500, but it has printed 600 700 and also some garbage values also, and also some garbage values. And if you press any key, our output window is not getting closed, because it is searching for the it is confused. It got confused. The array size is only 5, but we accessed 6 and 7. So here 600 700 and remaining all these values are memory leaks. These are called memory leaks. When we access the element which is not in the array, when we access the block which is not defined, the sixth block is not defined but we accessed it. That's why these memory leaks we get, and our output window got stuck. Now we should again start our turbo C++ environment. This is the main issue with our turbo C++. So you saw our output window got stuck like this. We pressing any key, we can't get out of this. That's why uh, I have opened again once again our code. Now here accessing the not created block results to this type of lag and this type of errors. Now these errors are not thrown by compiler by naming any syntax, because we didn't do any error in syntax, so compiler couldn't get that error. While only running, we get the error at runtime. We get the error at runtime because when we run the code, our code, what it does, it checks it tries to get the value in the fifth block and sixth block also. Then it continuously searches for that block and it tries to get the output. That's why here the process stopped. It is still searching for that blocks, but it is not finding that block. That's why this output window got stuck here. But this 600 and these 0, these are memory leaks. These are called memory leaks. That's why they got printed. Now let's remove those and try to uh, print the output. You can see a perfect output. You can see perfect output. So this type of mistakes we shouldn't do, because compiler also doesn't throw any error. I hope you guys understood. Now here, okay, now here you can see our beautiful array got printed: 100, 200, 300, 400, 500 without any error. Here I press any key, I came out from the output window. Here this is the process of arrays. Now our requirement was not reached still. Still we didn't reach our requirement. What was our requirement? Our requirement is to store 100 inputs from the user. Here now I can define the size 100. Sorry, instead I can define 700 also. I can take 700 blocks also in our RAM. Okay, but how to store? How to store into this? How to store into this? How to store 700 values by the user, from the user? How to get input from the user? And even though here, if the writing like this is also not a good way. Now we want to take from the user, so writing like this also we can't. Writing in this way also we can't. And also here a small question. Here writing 4 printfs is okay for writing 5 printf statements for 5 blocks, it's okay. Here there are 700 blocks. Here there are 700 blocks. Now we have to write 700 times printf. Is it correct? No, obviously not. Here we should find a small solution for writing a single printf line and getting all those 700 values. Here we can do this with for loops. For loops concept, as we discussed in the last episode. If you are not gone through the last episodes, all the links will be provided in the description. Please go and check out. Now reaching our requirement as per we discussed at the starting of the video will be continued in the next episode. So stay tuned. Do not forget to subscribe and like the video. If you do subscribe and like the video, it will be a great motivation to share more valuable content like this. So stay tuned. Thank you.